Hello and welcome to the introduction to the Master of Science in Energy. I'm Wolf Fruh and I am the Program Director for the students in Edinburgh and also for the distance learners. In the next few minutes, I'm going to explain first what we're trying to do, the aims of the program, and how we're trying to achieve this. Then what you need, the entry requirements, and once you come, what the year looks like, year structure, range of options, and what you can do in your dissertation. And we finish off with some ideas where you could go afterwards in terms of jobs. What are we trying to achieve? We aim that you gain a broad overview of the many aspects relevant to the energy sector and also relevant to your career, but with a firm understanding of the underlying engineering science principles and to give you the ability to apply them quantitatively, and then apply those principles to design a system fit for purpose and understand how those systems interact with other aspects, including economic aspects, policies, and environmental issues. How are we trying to achieve this? We have chosen to limit the number of mandatory core courses to a small number, 3 courses only, which cover an overview over the various energy engineering principles and the relationship of energy technology to society and the environment and business. And complementary to those few mandatory courses, we offer a large number of options from which you choose 5 from across the university. What is it you need to bring? Those are our entry requirements. Our standard requirement is that you have a good, honest degree in any engineering discipline or one of the physical sciences. Good means it's equivalent to a 2-2 Bachelor of Engineering or better. For international degrees, we have a standard comparison table to align foreign degrees to our British standards. If you have another good honest degree but not in one of those disciplines, then we are sure that you have got the right critical abilities, but we're not sure about the quantitative skills. So we need to have some evidence that you have sufficient quantitative skills needed for the analysis. So examples, some of the economics degrees or social sciences are actually skilled in statistics or modeling and therefore good enough. We look at those on a one-by-one case. And if you do not have a degree at all, we are also admitting people through an alternative route where we look at the whatever qualifications they have achieved, for example, higher national diplomas, and look how they've complemented that by sufficient certificated continued professional development activities, training courses in relevant subjects. Again, those applications are looked at on a case-by-case basis. Once you're here, what does the year look like? So our standard program structure is that you have 2 semesters of taught courses followed by a dissertation. Semester 1 from September to December, there you will take 4 courses. In semester 2 from January to April or May, you will take another 4 taught courses, and then you progress to the dissertation which you carry out between May and August. That is for the 1-year full-time study on one of our campuses in Edinburgh, Dubai, and Malaysia. You can also do the same as a 2-year part-time study. There you split each semester into 2 courses, semester 1, 2 courses semester 2 in the first year, then the remaining 2 from semester 1, remaining 2 from semester 2 in the second year, and end up again with the dissertation. We also offer this program for flexible learning as independent distance learner, where you can take up to 7 years to complete the program. I've mentioned that there are only a few mandatory courses, 3 mandatory courses. First one starts with the foundations of energy. This provides the context and the underpinning energy science. In semester 2, the other key mandatory course is called Technology Futures and Business Strategy, and in that course you place the engineering technology and its development over time into the context of opportunities given by changing energy policy and the energy industry. The third mandatory course is a research preparation course, which gives you the skills and the time to prepare for your dissertation. And then for the masters, the dissertation is the final mandatory component which you do for the summer. Alongside those 3 mandatory taught courses, you choose options, and you choose 5 courses in total. And rather than giving you a whole long list of individual course names, I've grouped them into subject areas, and each of the subject areas is covered by 2 courses, and you can choose from any of those. There are courses in oil and gas field subjects, the fossil fuel, the oil industry, courses covering renewable energy, technology and economics, electrical power systems and distributed generation, core mechanical engineering subjects, thermodynamics and computational fluid dynamics, energy management in buildings and demand management, then in a wider context, environmental impacts and climate change, project management, economics and management. The last, but by no means least important part is the dissertation. There you can explore any subject you want to deepen in. Here I've just listed some dissertation topics from last year, just to give you an overview of what might have been covered. We start with an overview, an energy systems analysis of Orkney's transport sector. Then one on evaluating renewable energy microgeneration technologies in the UK and Lithuanian households, a study on willingness to pay, so more from an economic aspect. Then a techno-economic assessment of hydrogen generation from offshore wind in Scotland. This particular project was carried out with an industrial partner. Another one, short-term wind speed prediction with neural networks using a European Centre database, so very much time series analysis and prediction, so very mathematical artificial intelligence subject. Then a bladeless wind turbines, a CFT study, so computational fluid dynamics. Analysis of the impact of surface states of the hydrodynamic thrust pads on the performance of a hydraulic machine with industry. So that was a very specific research task with a clear industrial application. Or developing eco-charcoal to empower rural and vulnerable communities in Southeast Asia. Temperature cycle analysis for a novel hybrid photovoltaic thermal device with industry again. Optimal sizing of solar thermal collectors for heat provision to Waterwhelm's novel water purification system with industry again. Effect of solar PV penetration on peer-to-peer electricity trading in microgrids operating in on-grid mode. Fault detection in an induction machine based on wavelet approach. So you've seen the range from systems analysis, economics, electrical engineering, mechanical engineering, data science, artificial intelligence. Just a snapshot of a few out of 100 dissertations covered in energy and renewable energy last year. What can you do with the degree? A whole range of options, opportunities, from consultancies in energy sector, wind farm developers, developers of devices, the utilities, or further studies. Here again is just a snapshot of a list of a few destinations of the most recent graduates. So one of ours went to natural power in the wind resource analysis the group based in Scotland. Another one went to Wood Group, also wind in the wind energy group. Waterwhelm, the photovoltaics company, snapped up one of our students who did the dissertation. One of our students went to Deloitte in England. And we've got a few French destinations: EDF, Électricité de France, Walk et Associés, a group of associates and consultants, Vinci Energy, also consultants, and then a number of students went on to do further PhD studies, either at Heriot-Watt or at other universities in the UK and Europe. Thank you.